Good morning. My name is Dinesh Raja. Today, me and my group members are going to talk about topic photonics. So first, I'm going to talk about the introduction. Next slide. Photonic is physical science of light waves. It deals with the science behind the generation, detection, and manipulation of light. Light has dual nature known as wave-particle duality. Moreover, light has electromagnetic wave and a particles called photon. And what is light made of? Light being made or consumed by a strong state gadget, for example, a laser diode or charge coupled gadget. For short, CCD. Finder is showing light's molecular nature. Next, I'll pass to Amirul to talk furthermore.
Thank you, Dinesh. Next slide. And I'm gonna talk about background history of photonics. The word photonics is derived from the Greek word phos, meaning light. Appeared in the late 1960s to describe a research field whose goal was to use light to perform functions that traditionally fell within the typical domain of electronics, such as telecommunication, information processing, and others. Next slide. The beginning of the field of photonics. Invention of the laser in the 1960s, laser diode in the 1970s, optical fiber for transmitting information, a beam dot fiber amplifier. Next slide. Though coined earlier, photonics came into common use in 1980s as a fiber optic data transmission was adopted by telecommunication network operators. Its use was confirmed when the IEEE Laser and Electro-Optic Society established an archival journal named Photonics Technology Letters at the end of 1980s. Next slide. How will achieving this goal have a great impact? During the period leading up to the dot-com crash circa 2001, photonics as a field focused largely on telecommunication. Photonics cover a huge range of science and technology application, including laser manufacturing, biological, and etc. That's all from me. Continue, Azim.
Thank you, Amirul. Okay. In classical optics, photonics is closely related to optics. When Albert Einstein explained the photoelectric effect in 95 centuries, optics preceded the discovery that light is quantized. Quantized. The refracting lens, the mirror, and various optical components known prior to 1900. These are lists of optics tools. Next. Each area has slightly different connotation by scientific and government communities and in marketplace. Photonics is used to connect applied research and development. Modern modern optic related to quantum optics, optomechanics, electro-optics, optoelectronic, quantum electronics. Okay. Photonics are specifically connotes such as the particle properties of light, the potential of creating signal processing device technology using photons, the particle application of optic and an analogy to electronics. The term optoelectronic connotes device and optical function. Example, a thin film semiconductor device. The term electro-optic specifically encompasses nonlinear electrical optical interactions. For example, as bulk crystal modulators such as the focal cells. but also include advanced imaging sensor typically used to surveillance by civilian or government organization. Photonics also relates to the emerging science of quantum information in those cases where it employs photonics methods. Device that integrate both photonics and atomic device is also optoatomics, which is included in other of emerging fields. That's all for me.
Okay,
Thank
so
you.
now, hello. So my name is Muhammad Hafiz Najmi. So now, if we talk about application of photonics. So application of photonics is about use light, create light, and modified light. So light is more faster than electricity. So optic is the light moving through space and length. Photonics light heat solid and turn it into electronic and digital signal. So it's very useful in communication. For example, in the internet travels through optical fibers made of glass, such as email, Google, Facebook transfer music or video. Photonic technology also applied into television, smartphone, display, GPS, camera that capture light, etc. So it's technically about imaging form. Imaging photonic is a imaging form after information is captured and digitized. So and then we go to application in oil and gas. So in oil and gas, photonic technology is giving a precise information on temperature, pressure, and providing visual image of drilling, infrared, etc. In medical field, it's also implement the photonic technology also on in the microscope that always used in the lab, laser eye surgery, which is if you don't want to wear any eyeglasses anymore, and camera in endoscopes. And we have in agriculture specified to spectroscopy. And in this field, we have a sensor and cameras and reactors enable the analysis of the land and the crop where areas need fertilizers. Which called precision agriculture, and we also have city farming, which is night vision goggles and high resolution imaging era. And then that's all from me, and thank you.
Okay, next proceed to me, Buddha Akila will explain to you about future trends for the photonics. Okay, I pick the fighting with the COVID. It is an effective sterilization, quick diagnosis, or to study, develop a better understanding of pathogen. Photonics help the fight against the pandemic on several sides. So as we can see, UVC light reliably destroy the SARS-CoV-2 virus in a wavelength range of about 250 nanometers. The mechanism of action in the chemical element thymine absorb the UVC wave in the virus nuclei, which destroy the virus and stop it from the spreading. So the modern system are able to capture the body temperature of several people at the same time. The key to contain the pandemic is early detection of infection. Imaging system based on the high resolution thermal imaging camera can help by recognizing people who are potentially affected on the basis of their race, body temperature. As you can see that when you go to shopping mall, right now before you enter, you will see the temperature, imaging temperature. So the contactless and thanks to the modern infrared lens, high resolution system focus on the inner canthus between the eye, nose, and measure with the level of accuracy to a 10 of a degree. So new solution approaching by photonic analysis of infected cell using Raman microscopy based on the principle that photon insert in the sample via laser interact with the biomolecules. Their energy level falls, which produce a scattering spectrum that is characteristic for the respective molecule. Implemented in a highly sensitive Raman trapping microscope, the principle can be used for the COVID diagnosis, especially as investigate body cell and be fixed in the laser focus with the optical tweezer for the Raman analysis. So, an illustration of the graphene based on COVID-19 spike protein detect the process. This is the imaging for the Raman microscopy. So the white rectangle represent the substrate with the graphene functionalized with the SARS-CoV-2 antibody shown in the yellow. When this graphene detected interact with the virus spike protein in the COVID positive sample, its anatomic vibration frequency change. So as the conclusion, we can conclude that photonic technology are amazing, fascinating, and anywhere low cost, much faster. Also, the scope of photonic device can expand with the COVID-19 outbreak. So the global photonic market was valued at $589.82 billion USD in 2020. By 2026 is expected reach 1 billion. So that's all from us. Thank you.